Hello, good morning. Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Similarly, daily one CSIR question I am teaching to you. We are under the mathematical methods of physics. Once again, you have to see the syllabus of the mathematical methods of physics. Why I am teaching daily these things? Because it should be imprint in your mind. What is there? In CSIR is a scientific council of scientific industrial research. This is one public sector undertaking company, public sector under the DST, Ministry of the DST, Department of Science and Technology, right? So these people will conduct every year two times exam. They will conduct. One is June, another one is the December, right? So after Corona, some mismatch came, but even though every year two times they will conduct the exam. There they will conduct in 5 streams, but we are teaching about the physical science. In the physical science, the first topic is mathematical methods of physics. Which one it is? Mathematical methods of physics. This is the first paper, mathematical methods of physics. Why we need the mathematical methods of physics? If we know the mathematics, then only we have to interpret the physical concept. That's why we have to use the mathematical methods of physics. Clear? There in mathematical methods of physics, the first topic is dimensional analysis. The second topic is vector algebra and vector calculus, right? The third topic is linear algebra. In the linear algebra, matrices, Cayley-Hamilton theorem, matrices, Cayley-Hamilton theorem, and eigenvalues and eigenvectors. Eigenvalues and eigenvectors are there. The fourth one is linearly ordinary differential equation. In linear ordinary differential equation, we have to take it as a first order and second order linear ordinary differential equation. The fifth one is special functions. Under the special functions, already I told the special functions. Under the special functions, 4 special functions are there according to your syllabus: Hermite polynomial, Legendre polynomial, Legere polynomial, and Bessel polynomial. Right? So these are the symbols of the polynomial: Hermite polynomial, Legendre polynomial, Legere polynomial, and Bessel polynomial is there. The sixth one is Fourier series and Fourier transforms and Laplace transform. Fourier series, Fourier transform, and Laplace transform. Now the seventh one is complex analysis. We are under the complex analysis. Under the complex analysis topic, this is the core syllabus of the CSIR. Under the complex analysis topic, we discussed about the elements of complex analysis. Elements of complex analysis, right? The second one is analytical function. The third one is the Taylor series, right? Taylor series. The fourth one, this one is the fourth one. That series we call it as a Laurent series, right? So this is the syllabus. Poles and residues and evaluation of the integrals. Those things are there. Those things I have to teach. So tomorrow and after tomorrow, one question I have to teach daily. One topic I am taking. So from that topic, any CSR question is there. That question I am teaching to you. So based on the topic. Now you have to see CSR December 2014. CSR December 2014. This question was asked from the Laurent series. The Laurent series expansion of the function f of z is equal to e power z plus e power 1 by z about z is equal to 0 is given by. They are giving the options: summation n is equal to minus infinite to plus infinite, z to the power of n is divided by n factorial for all values of modulus of z is less than infinite. Option B is summation n is equal to 0 to infinite, z to the power of n plus 1 by z to the power of n is into 1 by n factorial only if 0 is less than modulus of z is less than 1. Or option C is summation n is equal to 1 to 0 to infinite, z to the power of n plus 1 by z to the power of n 1 by n factorial only if 0 is less than of modulus of z is less than infinite. So option D is summation n is equal to minus infinite to plus infinite z to the power of n by n factorial only if modulus of z is less than 1. What is our function? Our function is f of z is equal to e power z plus e power 1 by z is there. This is our function. We have to expand in terms of the e power z is f of z is equal to e power z plus e power 1 by z. We have to represent in terms of a Laurent series form. Which form we have to represent? In terms of the Laurent series form we have to represent. How we have to represent the Laurent series form? Once you have to see. We know the exponential symbol e power z, e power x is equal to, there is a formula, e power x is equal to, it is a series 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on is there. This is the series, exponential series is, right? Now you have to take here e power z is equal to 1 plus z by 1 factorial plus z square by 1 2 factorial plus and so on is there. This is the series. Once you have to take e power 1 by z is equal to, which one we have to write here? 1 plus 1 by 1 factorial into 1 by z plus 1 by 2 factorial into 1 by z whole square plus and so on it will come. Now you have to add f of z is equal to e power z means we have to take it as a e power z. What we have to write this one? Once you have to see summation n is equal to 0 to infinite, summation n is equal to 0 to infinite z to the power of n by n factorial we have to write. Clear? Z to the power of n by n factorial. This one how we have to write? Summation n is equal to 0 to infinite 1 by n factorial into z to the power of n. I am writing 1 by n factorial into z to the power of n. Correct? Now you have to see e power z plus e power 1 by z, which is equal to f of z is equal to. Clear? F of z is equal to e power z means what should I write? Summation n is equal to 0 to infinite z to the power of n by n factorial plus summation n is equal to 0 to infinite 1 by n factorial into z to the power of n. Now you have to take the common. So what you have to take the common? Summation n is equal to 0 to infinite. Here n 1 by n factorial you have to take the common. Z to the power of n is divided by 1 by z to the power of n into 1 by n factorial. What we have to write? For all the values of, for all the values of what? For the all the values of all the values of 0 is modulus of less than is modulus of z is less than a to infinite. This is your answer, f of z. This series we call it as a, which series it is? Laurent series. Once you have to check the options, what is our option? Once you have to see summation n is equal to 0 to infinite z to the power of n plus 1 by z to the power of n into 1 by n factorial only if so 0 is less than modulus of z less than n infinite. This is your correct option. Option C is correct. Option B, here 1 is there, the limit is 1 is there, that is not 1 because it is a infinite series. Clear? So like that you have to take. What is exactly the Laurent series? The Laurent series, how we have to write? Once you have to see, the Laurent series is, this is very important. So many times your competitive people are asking the question based on the Laurent series. F of z is equal to, the Laurent series, f of z is equal to what we have to write? Summation n is equal to 0 to infinite an into z minus z0 whole to the power of n plus z minus z0 whole to the power of n plus summation n is equal to 1 to infinite. So 1 to infinite, you have to take one more constant, that is bn into z minus z0 whole to the power of minus n. Here a n, b n are constants. Those constants also we have to learn after some time. This series we call it as a, which series it is? Laurent series. Here, so z minus z0 whole to the power of minus n coefficients are there. Z minus z0 whole to the power of n coefficients also is there. Such type of combinations we call it as a Laurent series. Clear? So if you like my teaching, please download our app. That my app is Quantum Online Academy app. Go to your Play Store, take your so which one you have to take? This app you have to take, and go to stores in that app and see the courses. Some free classes also available. You have to listen and enjoy. And if you want to purchase the courses, those courses are available now. One is the CSIR and gate physics, another one is the JL physics, another one is a DL physics, and one subject also we are keeping the course, that is CSIR and gate mathematical methods of physics. Maybe couple of days, maybe within 10 days we have to finish this course. So it is totally recorded. Other courses are live plus recorded classes are available. You have to take, it will be useful to you. So, and you have to listen our classes in our YouTube channel. Please share and subscribe our YouTube channel. This is your Dr. Nagaraju Pendam. So tomorrow we have to see one more important question from the complex analysis. Thank you. Thank you for watching our YouTube channel.